So welcome to the next episode of electricity. So we are still on electrostatics. So but in this episode, two, we are going to be dealing with capacitors and capacitance. So what is capacitor? Capacitors is instrument we use to store charges. So capacitors are instruments we use to store what? Charges. Now what is capacitance of a capacitor? Capacitance of a capacitor is the ratio of the charge stored by the capacitor to the potential difference between what? The plates of the capacitor. So we can answer that what the capacitance equal to what? Q over V. Here C is what? Is the capacitance, and Q is the charges, the V is the voltage. The potential difference is also like voltage, you understand? So we have capacitance equal to Q over what? Over V. That is the formula for capacitance. So we have the C to be capacitance in farads. The unit of capacitance is what? Is farad. So sometimes you are going to have values like let's say we have it to be 20 microfarads. So micro is what? Is 10 to the power minus 6. So that one should not be new to you. So we have the one to be what? 10 to the power minus. So this one is what? 20 times what? 10 to the power minus 6 farads. So I'm just giving you an example because it is very, very common in solving what? When you are solving capacitance. Microfarads mainly is what? 10 to the power minus 3. When you have other one like femto is what? 15. 10 to the power minus 15. Now let us move on from there. So the next one is what? Is the charge. The charge is what? Is in coulomb. So we have already done something that have to do with charge, and you know the charge is what? Is coulomb. The next one is what? Is the voltage. The potential difference is what? Is voltage. Is measured in volts. So we can answer that what? The capacitor is equal to what? Equal to charge over what? Is C over what? Over V. I hope you understand. That is another thing. So the next thing, another formula you have to take note when you are solving questions on capacitance is this particular formula here. This second one, which is what? C equal to permittivity of the what? Of the substance. This E is what? Is permittivity of the what? Substance. And this area is what? Is area between what? The area of the what? Of the plate. And this D is what? Is the distance between the what? Between the plates. I hope you understand. So this is another formula for solving what? Capacitance. When they give you parameters that have to do with the charge, the voltage, you can solve your what? Your capacitance. When they give you values like the permittivity, the area, and the distance between the two plates, you can also solve what? You can also solve capacitance using these parameters. So in the next one, we are going to move on now to the capacitance in series and parallel. So we are going to talk about when it is in series and when it is in parallel. Now let us look into that. Capacitors in series arrangement. So now we are dealing with capacitors in series arrangement. So if you check this diagram now, this is the diagram of capacitors in series. Capacitors in series when we arrange them in series. So this is capacitor 1, this is capacitor 2, and this was capacitor 3. Now we arrange capacitor 1, 2, 3 in series what? Arrangements. Now if you check this one now, we have the voltage for this capacitor 1 here, we have the voltage for this capacitor what? 2 here, we have the voltage 3 for capacitor what? 3. If you check another thing now, you are going to see we write Q. There's no, we don't write Q1, Q2, Q3. So it means the Q is what? Is the same thing. So the first thing you have to take notice is that what? The Q, the charge of capacitors in series is equal. I hope you understand. So the charge of capacitor 1 is equal to the charge of capacitor what? 2 is equal to the charge of capacitor what? 3. That is, they have the same charge when you arrange them in what? In series. Another thing I want you to take notice is that what? The voltage. This is voltage 1, this is voltage 2, this is voltage 3. The total voltage now is going to be V equal to V1 plus V2 plus V3. So the total voltage in arrangement, in series arrangement, is what? Is the addition of all the voltage in the arrangement. So when you are dealing with series, the voltage, the total voltage is going to be the addition of voltage 1 plus voltage 2 plus what? Voltage 3. Let's say you have like 10 series, it's going to be V1, V2, V3 to V10. You are going to add them together. That is the total voltage of the what? Of the cell, of the arrangement. Now, if you check it now, we have capacitor 1, capacitor 2, and capacitor what? 3. The formula for this arrangement is what? Total capacitance, 1 over total capacitance. Let's say total capacitance is what? Is CT. Let me put it this way. Let's say the CT. 1 over total capacitance equal to 1 over capacitor 1 plus 1 over capacitor what? 2 plus 1 over capacitor what? 3. So that is what? That is the total capacitance. So here now, what is here now? This is the formula to find the total capacitance, the total capacitors. Now, with that now, with that, if you have a situation, let me give you another formula to it. So there's a formula for what when we have just two capacitance. So when we have some two capacitance, we can have it in this form and put it here. Then put it here. So we can have it in form like CT equal to C1 times C2 over C1 plus C2. So when you have a situation whereby the capacitors are just two, maybe you just have two capacitors, so you are just going to have it to be C1 times C2 over C1 plus what C2. That is one formula for that. Now, the major point of this particular part now is to know what the total voltage of the capacitors in series arrangement, which is what the addition of all the voltage. The total charges is the same charge. The same charge will flow through what everything, like the same charge. Charge of capacitor 1 is equal to charge of capacitor 2 equal to charge of capacitor 3. Then the last one is the total capacitors of the arrangement. So we have the total capacitor 1 over the total capacitors equal to 1 over C1 plus 1 over C2 plus 1 over what C3. So like what I said in episode 1, I told you here now we are not going to be solving questions. I'll just be giving you the how to solve questions. Then there's going to be another episode that deals with solving questions on electrostatics. So moving on, so we now have these capacitors in parallel arrangement now. So this is the capacitors in parallel arrangement. So how do I know this one is what is parallel? If you check the capacitor 1, 2, 3, you can see it is not one line that is joining them together. That is one thing I want you to know. But when we are dealing with in series, we draw something like C1, C2. You can see it is just one line that is joining what C1 and what and C2 together here. But in this parallel combination, you are going to see this one is what C1. It is not one line because this line that is joining this C1 is not the same line that is joining this one, because this is another line that is stopping. This line stop here. This line stop here. It is not the same line. You understand? That's why we know this one is not what is not a series arrangement. This one is parallel arrangement. Now, what you have to take note in parallel arrangement is that from this diagram now, you already know the charge 1 is not the same thing as what charge 2. It can be the same thing, but they are not equal. So it can still be 2 depending on the capacitor. Maybe if these capacitors are the same thing, this Q can be what can be the same thing. You understand? But in this context now, Q1 is not necessarily equal to Q2, and Q2 is not equal to what Q3. I hope you understand. So if they are not the same thing, they are not equal. Q1 is not equal to Q2, is not equal to Q3. Capacitor 1 to be C1, capacitor 2 to be C2, capacitor 3 to be C3. Now you check it now, there's something like V1, V2, V3. So it means the voltage in capacitors in parallel arrangement is what is the same thing, is equal. You get it is the same voltage that flow through what through the whole circuit, the whole arrangement. So it means here now voltage is equal. Q1, Q2, Q3 they are different from each other. Don't forget that since we have it to be, don't forget we have C equal to Q over what? Over C over V. Right? V. So you're gonna answer that what it is V equal to what? Q over C. In this context, so we can put it this way. V equal to what? Q over C. You can solve it that way. So another way you can do it is by doing MPG, you understand? So since you have C equal to Q over V, let's say C equal to Q1 over V, then C1, let me put it this way. Let me talk about the capacitors arrangement before I dive into this particular part. So don't forget that capacitors in parallel arrangement is what is C total equals to C1 plus C2 plus C3. So let me tell you the difference between the parallel arrangement and the series arrangement before I move into more content of this parallel arrangement. Now, in series arrangement, the capacitors total is what 1 over CT equal to 1 over C1 plus 1 over C2 plus 1 over C3 to anywhere. And the voltage is what the total voltage is what V equals V1 plus V2 plus V3. And the capacity and the quantity of charge, the charges are what? Charges are what? Q. Q is what is equal. Q1 is equal to Q2 is equal to what? Q3. The charges are the same. Now, in parallel arrangement now, the charges are not the same. Q1 is not equal to Q2 and Q2 is not equal to what? Q3. But the voltage are what? The same. So in parallel arrangement, the voltage is the same. In series arrangement, the what? Charge is the same. Take note of that. And for the formula, for the total, for finding the total capacitor in series arrangement is 1 over CT equal to 1 over C1 plus 1 over C2 plus 1 over C3, and in parallel arrangement is what? C total equal to what? C1 plus C2 plus C3. Then you are going to get your total arrangement. So there's a way we can manipulate these formulas to get whatever we want to get. But while we are solving question, I'm going to be showing you how to get some stuff from this C equal to Q over V. There's a way you can do stuff like that, then you know what to do. You know V is the same thing here, so you can just say V equal to Q over C and everything. You can do stuff like that and you are going to get it. I hope you understand. But for now, let us just talk about the major thing we are going to talk about in this part. Now let's talk about the last part, which is energy stored in a capacitor. Energy stored in a capacitor is also the work done in charging a capacitor. Put it that way. You can put it that way. So the energy stored in a capacitor is also equal to the work done in charging the capacitor. So the formula for energy stored in a capacitor is giving us energy equal to 1 over 2 CV squared. 1 over 2 CV squared. This is the formula for what? Energy stored in a capacitor. Don't forget that we have C equal to Q over V. So if we replace this C with Q now, we can now say 1 over 2 times Q over V, which is this one, times your V squared. One V is going to cancel one V here. So we can say 1 over 2 QV, which is 1 over 2 QV. I hope you understand. So that is it. We can also replace this. We can also replace this V. We can also replace the what? This V. You know, we have C equal to Q over V. So we can say V equal to Q over what? Over C. So if we replace this V here, we are going to have, you know, here V is what? Q over C, right? So if we place this V in this situation, like 1 over 2 CV squared, if we place this V with Q over C, we can now say 1 over 2 times C times Q squared over C squared. So 1 C cancels 1 C here. So we are going to have 1 over 2 Q squared over C. Yes. So now if we multiply it, we are going to have Q squared over 2 C. So that's how we got what? That's how we got this particular formula here. So it's still the same thing. You understand? It depends on how you understand, depending on the parameters give you in the question. So if they give you parameters I have to do with capacitance and voltage, just use your 1 over 2 CV squared. If they give you your charge and the voltage, just use 1 over 2 QV. If they give you your charge and the capacitance, just use Q squared over what? Over 2C as your formula for the energy stored in a capacitor. So that is going to be everything on capacitance, capacitors, energy stored in a capacitor. I hope you understand. So that is the summarization of electrostatics. So the next episode on electricity now is going to be on, it should be on question solving on this electrostatics before we dive into the current electricity, or it is actually more possible for us to dive into the current electricity before solving questions under the electrostatics.